Hello everyone, my name is Viswajith and I am currently pursuing my second year on AI/ML at Saveetha Engineering College. Today I will be presenting on QR decomposition using Schmidt process. Let's begin by understanding what QR decomposition and why we use the Schmidt method. So what is QR decomposition? It is a method in linear algebra when a given matrix A is factorized into a product of two matrices Q and R, and here Q is orthogonal matrix, which is its columns are perpendicular unit vectors, and R is an upper triangular matrix. This process is used solving linear systems, performing least squares approximation in numerical stability for matrix computations, and there are another points like QR decomposition simplifies calculations in machine learning algorithms such as solving regression problems, and the Schmidt process is a systematic way to generate orthogonal vectors needed to form a Q matrix. So now let's look at the sample question. Here we have a given specific matrix and we need to decompose it into Q and R using the Schmidt method. The main steps involving taking the columns of the matrix, applying the Schmidt orthogonalization process, and then normalizing them to form a Q. Once Q is found, the R matrix is calculated as the product of Q transpose and A. Next we have the program 2 that implements this process. Let's quickly understand the key steps of the code. So first, the matrix A is defined as input. The program creates an empty matrix to store the orthogonal vectors. Then using loops it subtracts the projections of each column onto the previous orthogonal vectors to make them perpendicular, and after the orthogonalization each vector is normalized to create the columns of Q. Finally, the upper triangle matrix R is calculated by multiplying the transpose of Q with A, and this code shows how the Schmidt process can be automated to obtain accurate Q and R matrix. So I would like to conclude that QR decomposition using the Schmidt process is a powerful technique for simplifying matrix operations and solving equations efficiently. Thank you for listening to my presentation.